Today we are going to simplify, multiply, and divide rational expressions. First off, what is a rational expression? We know that a rational number is anything that can be written as a fraction. For example, 18/5 is a rational number. A rational expression is when we add a variable or two into our fraction form. We might have variables added or subtracted on our numerator and denominator, or we might be multiplying our variables by a number out in front. Let's begin by simplifying a regular rational number, something like 18/24. We could simplify this fraction by finding a common factor that we could divide both the top and bottom numbers by. Both 18 and 24 are divisible by 6. So we can simplify this fraction into 3/4. An alternate way we could have simplified this would be to rewrite the 18 and the 24 as a product of factors. 18 is the same as 6 times 3. 24 is the same as 6 times 4. Because we have a same factor of 6 on the top and bottom, this is like a form of 1. 6 divided by 6 is 1. And so we can really just cross those out, and we see that we're left with the same answer of 3/4. Now let's simplify a rational expression. Notice how it still looks like a fraction, but we've included the variable x on the top and the bottom. We could split up the top into 9 times x. On the bottom, 27 is the same as 9 times 3, and x squared is the same as x times x. Look for the same factor on the top and the bottom to cancel out. Again, this is a form of 1. 9 divided by 9 is 1, so they can go away. We can also cancel out an x on the top with an x on the bottom. We are left with 3x on the denominator, and what do you think we will write on the top? That's right, we are just left with 1. Our simplified answer is 1/3x. Here is another rational expression. It's a little more complex than the last problem, but our process of simplifying will be very similar. First, we must factor the numerator and the denominator. On the top, x squared minus 16 represents a difference of squares. We can factor this into x plus 4 times x minus 4. Remember that if we multiply this out using FOIL, we should get the same thing we started with over here. To factor out the bottom, we are looking for two numbers that multiply to -12 and add to -1. Can you think of the two numbers? That's right, x minus 4 times x plus 3. Now we're looking for common factors on the top and the bottom. We have a common factor of x minus 4, so that means that we can cancel that factor in the same way we did on earlier problems. Our final answer, we are left with x plus 4 over x plus 3. Before we move on to the next set of problems, I almost forgot to tell you that we need to list out any restrictions on the variables. Kind of like finding the domain for the expression. What are the possible values of x? Back to this simplifying problem. the value of our denominator can never be equal to 0. And so if x was 0, 3 times 0 is 0, and that is not allowed. So for our restriction, we're going to say that x cannot be 0. What do you think the restriction would be for this problem? What is the value that x cannot be? That's right. X cannot be -3, because if x is -3, that would make our denominator equal to 0. Next, we are going to look at multiplying rational expressions. Now let's go back to the rule for just multiplying rational numbers. Algebra is just like arithmetic, except variables are used to represent the numbers. The arithmetic rules are the same as the algebra rules. Remember, for multiplying two fractions, our rule is to multiply across the top and multiply across the bottom. This gives us 180 divided by 45. Now we always want to simplify any fraction answer that we are left with. Right away, I see that 9 is a common factor of the top and bottom. 45 divided by 9 is 5. 180 divided by 9 is 20. Now I notice that there is yet another common factor between the 20 and the 5. They can both be divided by 5. So I'm actually doing my simplifying here in a few steps. We get 4 over 1, which is really just the same thing as 4. Now I want to show you an alternate approach. We'll call this method 2 for solving the same problem. We can actually simplify some numbers in this problem before we multiply across. Looking at the 18 and the 9, notice how we have a common factor of 9. We can actually rewrite that as 9 times 2 for the 18, okay, over 9 down there. And then looking at the 10 and the 5, we have a common factor of 5. So let's rewrite the 10 as 5 times 2. Keep the 5 over here. Because we're just going to be multiplying across the top and across the bottom, the 5 on the top will cancel out with the 5 on the bottom. 5 divided by 5 is 1, so that's going to go away. And then we have a 9 in common on the top and the bottom, so we can divide out the 9 from both, giving us another form of 1. See how we are left with 2 times 2, which is going to give us the same final answer of 4 over 1, or simply 4. Here is a problem that involves multiplying rational expressions. Notice how we've got the variable x in there. We can simplify this fraction, these fractions again before we multiply across. If we look at the 14 and the 7, we see that they have a common factor of 7. So we are going to divide each number by 7. 14 divided by 7 is 2, and 7 divided by 7 is 1. Now let's look at the x's. We have one x on the top. We have two x's on the bottom. If we divide the top and the bottom by a single x, x divided by x is 1. X squared divided by x leaves us with a single x. And finally, looking at the 9 and the 3, we can divide out a common factor of 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. Now when we multiply across the top, we are going to be multiplying together 2 times 1 times 3, giving us 6. And on the bottom, we are multiplying 1 times 1 times x, which is just x. In this last multiplication problem, we are going to factor each numerator and denominator first, and then look for common factors that can be canceled from the top and the bottom. To rewrite this first rational expression, we have a difference of squares on the numerator. We can factor this into x plus 3 times x minus 3. On the bottom, we are looking for two numbers that multiply to 4 but add to negative 4. We can do x minus 2 and x minus 2. For the other fraction, how would you factor the top? That's right, x plus 2 times x minus 2. On the bottom, we want two numbers that multiply to negative 6 and add to negative 1. Can you think of two numbers that would work? That's right, negative 3 and positive 2. Now let's look for common factors on the top and bottom. Right away, I see that we have an x minus 3, so we are going to cancel that. I also see that we have an x plus 2, so that goes away. And we also have an x minus 2. Altogether, we are left with only x plus 3 over x minus 2. The last thing we will be looking at today is dividing rational expressions. Again, let's start by looking back at a regular division of fractions problem, because the rules for arithmetic will be the same rules for the algebra. Remember that when we are dividing fractions, we want to keep the first fraction the same, turn our division symbol into multiplication, and then take the reciprocal of the second fraction, which means we're flipping the numerator and the denominator. When I taught middle school, I used to teach my students this method: copy, dot, flip. Copy, dot, flip, copy, dot, flip. Copy the first fraction, keep it the same, dot, change to multiply, and flip the second fraction. Then it turns into a multiplication of fractions problem, so we multiply across the top and we multiply across the bottom. Now let's look at a division problem that involves rational expressions. Similar to the first step we did in the last problem, we are going to rewrite this as a multiplication problem using copy, dot, flip. Copy the first fraction, change to multiplication, flip the second fraction. Now before we multiply across the top and multiply across the bottom, let's look for those common factors that may be able to be canceled out before. Between the 5 and the 15, we have a common factor of 5. 5 divided by 5 is 1, and 15 divided by 5 is 3. Looking at the other side, between the 4 and the 20, they have a common factor of 4. 4 divided by 4 is 1. 20 divided by 4 is 5. And finally, between the x and the x squared, have a common factor of x. X divided by x is 1. X squared divided by x is a single x. Now when we multiply across the top, we have 1 times 1 times 1. And across the bottom, we have 5 times x times 3. One more division problem. Because we have all of the trinomials, they will all need to be factored before we can cancel out common factors. We also have that division symbol, so we have to copy dot flip. You can factor them first and then copy dot flip, or do it the other way around. Let's go ahead and get these guys factored, and then we'll rewrite it as a multiplication problem. For our first expression, get our parentheses set up. Let's see, we want two numbers that multiply to 27 and add to negative 12. So we can do -9 and -3. On the bottom, multiplies to 36, adds to negative 13, -9, and -4. We'll go ahead and continue to write it as the division problem. On the other fraction, let's look at the top, two numbers that multiply to 9 and add to negative 6. Got y minus 3, y minus 3, and on the bottom multiplies to 16, adds to negative 8, y minus 4, and y minus 4. Let's go ahead and copy dot flip to turn this into a multiplication problem. All right, let's start looking for common factors and doing some canceling. We can cancel our y minus 9s, we can cancel our y minus 3s, and our y minus 4s. All together, we're left with y minus 4 over y minus 3. Thank you for watching my lesson on simplifying, multiplying, and dividing rational functions. I hope the methods presented to you in this lesson made sense, and if you have any additional questions after completing the homework, I will answer them in class on block day. Thank you, and I will see you then. Bye-bye.